Hi everyone, and today we are going to see lecture number 11. So today we are going to continue with lecture number 11, right? See, up till now we have completed 10 lectures, right? And right now we are dealing with coordinate systems, that is third chapter, coordinate systems. So in this we have completed a rectangular coordinate system as well as cylindrical coordinate system, and also we have started a spherical coordinate system. So in the last lecture we have studied about what do you mean by r, theta and phi, and also we have seen how to convert or how to represent these spherical coordinates in terms of rectangular coordinates and vice versa, right? So after that we have seen how to represent the unit vectors ar cap, a theta cap and a phi cap, right? Okay, so all these things we have seen in the previous session, right? Okay. So in this lecture right, so in this lecture we try to do the second method here. We try to do the second method in order to determine what? In order to determine AR cap, A theta cap and A phi cap. So I will explain the second method in order to determine AR cap, A theta cap and A phi cap. Okay. So already A phi cap, that is the definition of phi will remain same as in case of cylindrical coordinate system. So that's why we have already derived this a phi cap, and what we got for a phi cap we got it as minus sin phi ax cap plus what? Plus cos phi ay cap. So there is no need to derive again this one here. There is no need to derive again this a phi cap, right? So we try to derive the expression for ar cap and a theta cap, right? Okay. So now see here. So let us consider this is z axis. So I am explaining the second method to determine AR cap and A theta cap. We know already what is A phi cap, right? So this is z axis, and let us say this is y axis, and let us say this is x axis, right? Okay. So now here I am considering one semicircle, that is vertical circle like this, right? And here I am considering one horizontal circle like this, right? One horizontal circle like this, right? Okay. So now see here. So this is let us assume this is the center of the sphere. This is the center of the sphere. So the distance from the center of the sphere to any point on the surface of the sphere is nothing but what? Is nothing but radius of the sphere. Okay. So let us assume the radius of the sphere is 1 unit. Radius of the sphere is 1. Okay. So I am representing this radial vector as what? As AR cap. So its magnitude is 1, right? Okay. So this is AR cap. Next, A theta cap. So A theta cap is nothing but the tangent drawn to this vertical circle at this point. So if you draw the tangent from top to bottom, so it is going to point in this direction. So this is nothing but what? This is nothing but A theta cap, right? Okay. So this is A theta cap, and if you draw the so here let us assume one horizontal circle is passing through this point, right? So now if you draw the tangent at this point to this horizontal circle, so this will give you A phi cap, right? Okay. So here we want to get the expressions for AR cap and A theta cap. Okay. So we don't want this A phi cap because already we have derived this A phi cap in case of cylindrical coordinate system. Okay. So just I have drawn AR cap, A theta cap and A phi cap here, right? Okay. So we don't want to derive this A phi cap. We have already derived this one, so I am removing this. So we want only this AR cap and A theta cap expressions, right? Okay. So now see here, see this is a theta cap, right? So in vectors we know that parallel shifting is allowed. So that means you can take this a theta cap without changing its direction. Without changing its direction, I can move this a theta cap from this location to what? From this location to this location, right? Okay. So this is, wait. So this is AR cap and this is a theta cap. So without changing the direction of a theta cap, I can shift this a theta cap from this location to here, okay, to origin. Or I am moving this a theta cap. The tail of the a theta cap is joined with what? The tail of AR cap. So I can do that or not? Yes or no? Because parallel shifting is allowed. So I am moving this without changing its direction. So I am moving this a theta cap. I am moving this a theta cap and keeping it at the tail of what? At the tail of AR cap. So this is nothing but what? This is nothing but let us say this is, okay. So this is nothing but a theta cap, right? So I can draw a theta cap in this manner. So this is AR cap and this is a theta cap. So its magnitude is 1, right? Okay, okay then, fine. So I hope it is crystal clear up till now, right? Okay. So now here now here I am drawing again this z axis, and here this is x axis, and here this is y axis, right? Okay. So here I am considering AR cap. Here I am drawing AR cap. Here I am considering AR cap, right? Okay. So this is AR cap. So this is AR cap, and its magnitude is 1, right? So we know that the angle between the radial vector and z axis is nothing but what? Is nothing but theta. Yes or no? The angle between this is nothing but what? Radius. Okay, we have considered the radius as 1. Okay, so the angle between the radius and z axis is nothing but what? Is nothing but theta, right? Okay. So now see here. So if I draw the normal, from the head of AR cap onto what? Onto XY plane. I am drawing the normal from the head of AR cap onto XY plane. So I am going to get the component of AR cap in XY plane. So this is the component. This is the component of AR cap in XY plane. So what is its value here? What is its value? Tell me. So here this angle is nothing but what? What is this angle here? So this angle is theta, and this vector is lying in XY plane. So the angle between z axis and this vector, see whatever the vector that you draw in XY plane, okay, so that vector is going to make an angle 90 degrees with respect to z axis or not? Okay, so that means the angle between z axis and this vector, the angle between z axis and this vector is nothing but how much here? 90 degrees. So what is this angle here? The angle between this AR cap and its component. What is this angle? Tell me. So this angle is nothing but this 90 minus theta. So this is 90 minus theta, right? Okay, so if this angle is 90 minus theta, then what is the value of this component? Tell me. So this is AR cap, right? Its magnitude is 1 and its component is this one, right? So the magnitude is 1. So 1 into cos of what? Cos of 90 minus theta will give you what? Will give you this component. Yes or no? So this component will become 1 into cos of 90 minus theta. So that is nothing but what? Sin theta. That is nothing but sin theta. Understood? Or you can analyze in this manner. So this angle is nothing but what here? 90 degrees. So this is forming what? This is forming a right angle triangle. This is the hypotenuse, this is adjacent, this is opposite side, right? Okay, so the angle between this AR cap and this one is nothing but 90 minus theta. So its component is nothing but 1 into cos of 90 minus theta, that is sin theta, right? Okay, so now see here. So this vector is in XY plane. So here, see here, the angle between x-axis and this vector here. So this component is present in xy plane. So we know that the angle with respect to x-axis, is nothing but what? Is nothing but phi. Yes or no? So this angle is nothing but phi. Right? So the angle made by this vector with respect to x-axis is nothing but phi. Right? So this is sine theta. So this vector, this is a sine theta. This vector is nothing but sine theta. Right? Okay. So it is making an angle phi with respect to x-axis. So now this sine theta is neither along x direction nor along y direction. So you can resolve this into two components. One is along x, another one is along y. Okay, so if you drop your normal from the head of sine theta onto what? Onto x-axis. You are going to get what? You are going to get x component. And if you drop your normal from the head of sine theta onto what? Onto y-axis, you are going to get what? You are going to get y component. So the distance from here to here, the distance from here to here, or I can say the distance from here to here. Okay. This will give you the y component and this will give you x component. Right? Okay. So the component of sine theta along x is nothing but what? What is the angle between these two? Is nothing but phi. So the component of the component of sine theta along x direction will become what? Will become sine theta cos phi. Sine theta cos phi. It is along which direction here? It is along ax cap direction. So sine theta cos phi ax cap. Understood? Okay. Okay. So next this this sine theta is also having the component along y. So what is its component along y here? Tell me. So the component along x is nothing but sine theta into cos phi. So the component along y will become what? Sine theta into sine phi. Yes or no? So this is x component here. This is x component, right? We got, and y component of sine theta along y direction is nothing but what? Is nothing but sine theta into sine phi. Sine phi. It is along which direction? Ay cap direction. So ay cap. Right? Okay. So this is the x component. This is the x component of sine theta, and this is the y component of sine theta. Right? Okay. So next see here. Now if I drop a normal from the head of AR cap, onto what? Onto z axis. Right? So the distance from here to here, will give you what? Will give you z component. So what is the z component here? Tell me. So the angle between this one and this one is theta. So 1 into what? Cos of theta. So that is, this z component will become simply cos theta. Right? Okay. So for this AR cap, the x component is nothing but sine theta cos phi ax cap, and for this AR cap, the y component is nothing but sine theta sine phi ay cap, and for this AR cap, its z component is nothing but cos theta. So you can represent AR cap. Now you can represent AR cap as what? As a x component. X component is nothing but sine theta cos phi ax cap plus what? Plus sine theta sine phi ay cap, and its z component is nothing but what? Its z component is nothing but cos theta az cap. Okay. So whatever the expression we got here, the same expression we got from the first method also. Understood? Okay. Okay. So what we have done, this is AR cap, it is neither along x nor along y nor along z. So we have determined the components of AR cap along ax, ay and az. That's it. Right? What we have done, we have dropped a normal from the head of AR cap onto xy plane. So we got the component of AR cap in xy plane. So whatever the component that we got, that can be resolved again into x component and y component. Right? So the x component, we got it as sine theta cos phi, y component we got it as sine theta sine phi, and if you drop your normal from the head of AR cap onto z axis, we got what? We got z component. So that is nothing but cos theta. Right? So this AR cap is having its x component as sine theta cos phi, and y component as sine theta sine phi, and z component as cos theta. Right? So this is the expression for AR cap. Right? Okay. Okay, yeah. So in the same manner, we can determine for a theta cap also, right? Okay, okay, yeah. So in this diagram, I am utilizing this diagram here, right? Okay. So see here, see this a theta cap, see this is the xy plane, right? This is xy plane. So a theta cap is like this, right? So this is xy plane and a theta cap is pointing like this. It is not in xy plane here, a theta cap is not in xy plane, right? So this is the xy plane, a theta cap is lying like this, understood? Okay, okay. So a theta cap is lying like this. Now see here, now I can drop a normal, from the head of what? From the head of a theta cap. See this a theta cap is neither, this is also neither along x nor along y nor along z. So it is going to have all the three components. So we are trying to determine all its three components here. Okay. So first what we have to do, just to drop a normal from the head of what? From the head of a theta cap onto what? From the head of a theta cap onto xy plane. So then you are going to get the component of a theta cap, right? So see here, so I can draw like this, right? Okay, this is a theta cap, its magnitude is 1. So if I drop a normal from the head of a theta cap onto xy plane, I am dropping a normal from the head of a theta cap onto what? Onto xy plane. So you are going to get the component, of a theta cap in xy plane. So that is nothing but what? That is nothing but this one, right? Okay, okay. So this is the component of a theta cap in xy plane, right? Okay, yeah. Okay. So now see here, now here, if you know the angle between these two, so cos of 1 into cos of this angle is nothing but this component, right? So we have to determine this angle. So how you can determine this angle here? See here, this angle we know that this is theta. This angle is nothing but theta, right? Okay, okay, fine. Next, this angle is theta. Okay, okay. So next, the angle between z axis and this one. See, this is lying in xy plane. So the angle between z axis and this one is nothing but what here? Is nothing but 90 degrees, right? Okay, okay. Next, right? Okay, this is 90. Next, what is the angle between AR cap and A theta cap here? We know that the angle between AR cap and A theta cap is 90 degrees. The angle between AR cap and A theta cap is 90 degrees, right? Okay, okay. So then what is this angle here? Tell me, what is this angle? See here, see this total angle here, from here to here, the angle is 90 degrees, right? Okay, okay. So this angle is theta. So this angle will become 90 minus theta, right? Okay. Wait. Or I will tell another way here, or otherwise. Wait. See. This is 90. Okay. This is 90 and okay, okay. See here, from z axis to this one is nothing but 90 degrees, right? Okay. So from here to here, it will become 90 minus theta, right? Okay, okay. So then what is this angle here? What is this angle? Tell me. And the angle between AR cap and A theta cap is nothing but what? Is nothing but 90 degrees. So now tell me, what is this angle? See here, from here to here, the angle is 90 minus theta, and from here to here the angle is 90. So 90 minus of 90 minus theta. So 90 minus of 90 minus theta is nothing but what? Is nothing but theta. So this angle is nothing but what? This angle is nothing but theta. This angle will become theta. I hope you have understood this one here, right? Okay, okay. So this angle is nothing but what? This angle is nothing but theta. See, the angle from here to here is 90. So the angle from here to here is 90 minus theta. The angle between AR cap and A theta cap is 90 degrees. So this angle is 90 minus theta, right? And this total angle is 90. So this angle will become what? Total angle 90 minus 90 minus theta. So that is theta, right? Okay. So I hope it is crystal clear. So now I am removing all this, right? Okay, okay. Right. So this angle is theta. So now right. So now see here. So this vector is neither along x nor along y. So this wait. So this is the vector now. This is the vector that we got in xy plane, right? So how you can represent this vector here? This is nothing but the component of A theta cap in xy plane. So that is 1 into what? 1 into cos of this angle. So 1 into cos of this angle is nothing but what? Cos theta. So this component is nothing but cos theta, right? So now this cos theta component, this cos theta is neither along x nor along y. So you can resolve this into two components. One is along what? One is along x and another one is along y, right? So this is nothing but what? This is nothing but y component, right? And this is nothing but what? This is nothing but x component. So what is the x component? You are going to get, tell me. See, what is the angle? What is this angle here? What is this angle? That is wait. So what is this angle? What is this angle? What is this angle? This cos theta is lying in xy plane. So the angle with respect to x axis is nothing but what? Is nothing but phi. So its x component will become what? X component will become cos theta into cos phi. Y component will become what? Cos theta into sin phi. Understood? So its x component will become cos theta into cos phi, right? The angle between cos theta and x axis is nothing but phi. So the component of cos theta along x is nothing but cos theta cos phi, and the component of cos theta along y is nothing but what? Is nothing but cos theta sin phi. Cos theta sin phi, right? Okay, okay. So next see here the angle between z axis and a theta cap. What is the angle between z axis and a theta cap here? What is this angle? Tell me. What is this angle? The angle between z axis and a theta cap. See here. See this angle here, the angle between AR cap and A theta cap, the angle between AR cap and A theta cap is 90 degrees. Okay, the angle between AR cap and A theta cap is 90 degrees, right? Okay, okay. So now see here, what is the angle between Z axis and A theta cap? The angle between, here I am drawing separately here, the angle between Z axis and AR cap is how much here? This is nothing but theta, and the angle between AR cap and A theta cap is how much here? 90 degrees. So the angle between Z axis, the angle between Z axis and A theta cap, the angle between Z axis and A theta cap is nothing but what? 90 plus theta, 90 plus theta. So what is the component of 1 into A theta cap along Z direction here? Is nothing but what? 1 into cos of the angle between A theta cap and Z axis. Understood? Okay, okay. So the angle between A theta cap and what? The angle between A theta cap and Z axis is 90 plus theta. So which means the component of A theta cap along Z direction is nothing but what? 1 into cos of 90 plus theta. Right? Okay. So that is the Z component here. So the Z component of A theta cap. So the angle between Z axis and A theta cap is how much here? 90 plus theta, 90 plus theta. So here it will be looking confusing, so you can consider this figure, right? Okay, okay, right. So now the z component, the z component of a theta cap is nothing but what? Is nothing but what we got here? 1 into cos of 90 plus theta, 1 into cos of 90 plus theta. So that is nothing but what? That is nothing but minus sin theta, okay. So the x component we got cos theta cos phi, y component we got cos theta sin phi, and z component we got minus sin theta, right? Okay, so that means I can write a theta cap is equal to, so its x component is cos theta cos phi, its x component is cos theta cos phi ax cap. Next, y component, what is its y component here? Y component is nothing but cos theta sin phi, cos theta sin phi ay cap, and z component is nothing but minus sin theta az cap, right? Okay, okay. So this is the expression for a theta cap. Okay, so we got the expression for AR cap here, sin theta cos phi ax cap plus sin theta sin phi ay cap plus cos theta az cap, and here the expression for a theta cap we got it as what? Cos theta cos phi ax cap plus cos theta sin phi ay cap minus sin theta az cap, right? Okay, okay, and we know the expression for a phi cap, so there is no need to derive this again. So we got a phi cap is nothing but what? Minus sin phi ax cap plus what? Plus cos phi ay cap, right? So this is the second method to derive what? To derive this AR cap, a theta cap, right? Okay, so a phi cap we have already derived in cylindrical coordinate system, so here there is no need to do it again, right? Okay. Sorry. Right, okay, okay. So this is another way to determine what? To determine the AR cap, a theta cap and a phi cap, right? So I hope it is crystal clear. So next here, next see here. So here we got AR cap is equal to sin theta cos phi ax cap. See, you can remember in this manner here, you can remember in this manner. See the component of AR cap, see here the component of AR cap in xy plane is nothing but sin theta, and this sin theta again resolved into x component and y component. So that is its x component is nothing but what? Sin theta cos phi, y component is nothing but sin theta sin phi, and z component is nothing but simply cos theta, because the angle between the radial vector and z axis is theta. So that's why it is cos theta. Understood? Okay, okay. So the AR cap is going to have the component in xy plane, that component is nothing but sin theta, that sin theta is resolved into x component and y component. So its x component is nothing but what? So first sin theta, it is resolved into two components along x, its component is cos phi ax cap plus what? This sin theta is resolved along y direction, so that is sin theta into sin phi ay cap plus this AR cap is going to make an angle theta with respect to z axis, so you are going to get a cos theta az cap. Okay, so in this manner you can easily remember, right? Okay, okay. Next, a theta cap. How you can remember a theta cap? So a theta cap is making an angle theta with respect to what? With respect to this xy component. So this is the xy component, yes or no? Okay, so this is the component that is present in xy plane, that is cos theta. So a theta cap is making an angle theta with respect to what? With respect to the component in xy plane, and this cos theta again resolved into two components, one is along x, another one is along y, right? Okay, okay. So a theta cap is equivalent to what? So its component in xy plane is nothing but cos theta. So this cos theta again resolved into x component and y component. Along x, its component is cos phi ax cap. Along y, the component of cos theta is nothing but sin phi ay cap. And the angle between a theta cap and az cap, or the angle between a theta cap and z axis is nothing but what? 90 plus theta. 90 plus theta. Understood? Okay. So cos of 90 plus theta is nothing but the component along z direction. So cos of 90 plus theta is how much here? Minus sin theta. So you can write here minus sin theta az cap. Right? Okay. Okay. So in this manner we can remember these expressions. And for a phi cap, we already know a phi cap is equivalent to what? Is equivalent to minus sin phi ax cap plus what? Plus cos phi ay cap. Right? Okay. So I can write this one in matrix form also here. So like ar cap here, a theta cap and a phi cap is equivalent to what? Is equivalent to, I can write it as what? I can write it as sin theta cos phi, and here sin theta sin phi, and here cos theta, and here cos theta cos phi, and here cos theta sin phi, and here minus sin theta. Right? For a phi cap it is minus sin phi, and here cos phi, and here 0. Right? Okay. So this into what? This into ax cap, ay cap and az cap. Okay. So you can represent in this matrix form also. Right? Okay. So the same thing you can do in case of cylindrical coordinate system also here. So there also we got the expressions for aero cap and a phi cap and az cap. So that you can represent in terms of this matrix form. Right? And the same matrix, if you want this ax cap, if you want ax cap, ay cap and az cap. Right? Okay. So this is equivalent to what? This is equivalent to, you can determine the inverse of this one here. If you want this one, then you can send this one to this side. So that will become what? That will become sin theta cos phi, sin theta sin phi, cos theta, and here cos theta cos phi, cos theta sin phi minus sin theta, and here minus sin phi cos phi 0 whole inverse into what? Into, you can write ar cap, a theta cap and a phi cap. So in this manner we can represent. If you write the inverse of this one, then you are going to get this one. Right? Okay. Okay. So you can represent ax cap, ay cap, az cap in terms of what? Ar cap, a theta cap and a phi cap. Or you can express ar cap, a theta cap, a phi cap in terms of ax cap, ay cap and az cap. Right? Okay. Okay. So I hope it is crystal clear. Right? Okay. Next. Okay. Okay. So up till now we have seen okay. So up till now we have seen how to represent the unit vectors, right? Okay. Okay. So in a spherical coordinate system here, in this spherical coordinate system, what are the differential lengths we got here? What are the differential lengths? So the differential length along r is nothing but what? Dr ar cap. And what is the differential length along theta? Along theta is nothing but r d theta a theta cap. And what is the differential length along phi? Is nothing but what? Is nothing but r sin theta d phi a phi cap. Right? Okay. So these are the differential lengths we got. So with the help of this differential lengths, we can form what? We can form three differential areas. Yes or no? So if you do the cross product between these two, you are going to get one differential area. If you do the cross product between these two differential lines, you are going to get another surface area, right? And if you do the cross product between these two differential lines, you are going to get another differential area. So whatever the procedure we have followed in cylindrical and rectangular, the same procedure we can follow in order to determine the differential areas and differential volume, right? Okay, so let us determine the first differential area. dA1 bar is equivalent to, so do the cross product between these two here. So I am writing directly here, I am writing directly. So what is the magnitude you are going to get? Magnitude is nothing but r into dr into d theta. So AR cap cross A theta cap is nothing but what? Is nothing but A phi cap. Now you are familiar, yes or no? So that's why I am writing directly, right? So A phi cap. Now here, what are the variables? R and theta are variables. So phi is what? Phi is constant. So we call this plane as what here? We call this plane as a phi equal to constant plane. We call this plane as phi equal to constant plane. So for phi equal to constant plane, the direction is along A phi cap direction. Here we are enclosing the surface from AR cap to A theta cap, right? Okay. So now now, what is the total surface area that we can expect here? What is the shape of the total surface area we can expect here? Tell me. Now, here the variables are nothing but r and theta. So, by varying r and theta, what is the surface area that we are going to get in spherical coordinate system? Okay. So, see here, let us assume this is z-axis, right? So, this is the center of the sphere, right? Okay. So, this is z-axis and this is the center of the sphere. So, now what are the variables? Variables are nothing but r and theta. So, vary r and vary theta. Theta is varying from where to where? 0 to pi. Understood? So, vary r and vary theta. 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 So, I will show like this. So, vary r and vary theta. 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 So what you are going to get? You are going to get the surface of a semicircle. Yes or no here? So if you go on vary r and theta, r and theta, r and theta, then you are going to get the surface area of a semicircle, isn't it? Okay. Okay. So let us check whether we are getting the surface area of a semicircle mathematically or not. Okay. So what you have to do here? So you have to integrate with respect to r and theta. So integrate with respect to r and theta. So let us say r is varying from 0 to r1 and theta is varying from 0 to pi. So here we are having r dr d theta a phi cap. So if you do this, what you are going to get? Tell me. So you are going to get integration of r is nothing but r square by 2, its range is from 0 to r1. Integration d theta is nothing but theta, its range is from 0 to pi, a phi cap, a phi cap. Understood? So if you do this, what you are going to get? Tell me. Substitute the range here, what you are going to get? You are going to get r1 square by 2 here, and here you are going to get pi, and here a phi cap. So what you are getting? Pi r1 square divided by 2 a phi cap. So pi r1 square, r1 is the radius of the sphere, r1 is the radius of the sphere. So pi r1 square by 2, pi r1 square by 2 will give you what? Will give you the surface area of a semicircle. Yes or no? Pi r1 square is the radius of a circle, surface area of a circle. Pi r1 square by 2 will give you what? The surface area of a semicircle. So this represents, this is the shape that you are going to get. So we got the shape as what? We got the shape as a semicircle, right? Okay. So semicircle of radius, let us say the radius is r1, the radius is r1, right? The shape of the semicircle we are going to get by varying what? By varying r and theta, by varying r and theta, right? Okay. Okay. So next here, next. So next consider another differential area, let us say dA2 bar, dA2 bar, right. So now do the cross product between this differential length and this differential length. So if you do the cross product between these two, what is the magnitude you are going to get? Magnitude is r square sine theta d theta d phi. So you are going to get r square sine theta d theta d phi, and a theta cap cross a phi cap is nothing but what? AR cap. So this is AR cap. So here the variables are nothing but what here? The variables are nothing but theta and phi, and hence it is called as what? It is called as r equal to constant plane. Theta and phi are variables, whereas r is constant. So we call this plane as r equal to constant plane. So for r equal to constant plane, the direction is along AR cap. Here you are enclosing the surface from a theta cap to a phi cap, right? Okay. So now see here. Now we try to get the total surface area. The total surface area A2 bar is equal to. So let us guess what is the shape of the surface that we are going to get by varying only theta and phi. So here r is constant, right? If you keep r constant and if you vary only theta and phi, what is the shape you are going to get? Guess here. See, let us consider this is z axis, this is the center of the sphere. So r is constant, right? So r is constant. Okay, so r is constant. Now what are variables here? Theta and phi, right? So r is constant. With r constant, if you vary theta, you are going to get a semicircle, right? Now if you vary phi, okay, that means you have to rotate this semicircle in anti-clockwise direction like this. Then what you are going to get? You are going to get the surface area of a sphere. So if you vary theta and if you vary phi, what you are going to get? You are going to get the surface area of a sphere, right? Okay, okay. So it is just like if you are having r, right? R is fixed here. So if you vary theta, you are going to get this semicircle. Now if you vary phi, that means if you rotate this by 360 degrees, so that means you are varying phi. So if you vary phi, then you are going to get what? The surface area of a sphere. Take the semicircle and rotate it. Take the perimeter of the semicircle and rotate it. You are going to get what? You are going to get the surface area of a sphere. So here r is fixed. What is varying here? Only theta and phi. So you have to get the surface area of a sphere, right? Okay. So let us check mathematically whether we are getting that result or not. So here the variables are nothing but theta and phi, right? So r square sine theta d theta d phi AR cap. So here theta is varying from 0 to what? 0 to pi. Phi is varying from 0 to 2 pi. So here r is constant with respect to integration variables. So you can take it out of the integration. So you are getting r square. So integral sine theta d theta is nothing but what? Minus cos theta. Its range is from 0 to pi. Next, integral d phi is nothing but phi. Its range is from 0 to 2 pi. The direction is along AR cap. Okay. Okay. So this is equivalent to what? This is equivalent to r square into, if you substitute the range, what you are going to get here? Minus cos pi. Cos pi is minus 1 minus what? Cos 0, that is 1, right? Okay. Multiplied by what? If you substitute the range, here you are going to get 2 pi. So finally what you are going to get? Here the direction is AR cap, right? So here minus of minus will become plus. So here you are going to get 2 plus 2 you are going to get. 2 into 2 pi is 4 pi. 4 pi into r square. So finally you are going to get 4 pi r square AR cap. So this is the surface area you are going to get by varying what? By varying theta and phi. By varying theta and phi, the surface area that you are getting is nothing but 4 pi r square. 4 pi r square, which is nothing but the surface area of a sphere. Yes or no? So here we are getting what? We are getting the surface area of a sphere, right? So we will get the surface area of a sphere, right? And what is the direction of the sphere here? What is the direction the surface of the sphere is nothing but what? AR cap. So that means if you draw a normal at any point on the surface of the sphere, it is going to point in which direction? It is going to point in AR cap direction, right? So take the surface of the sphere, and if you draw a normal on the surface of the sphere, it always points in which direction here? AR cap direction. Understood? Okay. Okay, so this is the direction of the surface of the sphere, right? Okay. Next, so another surface area, so that is A3. So what are the differential lengths here? dr AR cap and r d theta A theta cap and r sin theta right, r sin theta d phi A phi cap, right? So next another differential area dA 3 bar is equivalent to, so do the cross product between this differential length and this differential length, so that is A phi cap and AR cap. So if you do the cross product between these two, what you are going to get? Tell me. So write down the magnitude. Magnitude is nothing but r sin theta d phi dr. Okay, so r sin theta, I can write dr d phi, right? So into A phi cap cross AR cap is nothing but what? Is nothing but A theta cap. Okay. Okay. So here what are variables here? The variables are nothing but r and phi. So theta is constant. So we call this as a theta equal to constant plane. We call this as theta equal to constant plane. So for theta equal to constant plane, its direction is what here? Its direction is A theta cap, right? Okay. Okay. So now what is the total surface area? A3 bar is equivalent to what? Now here what are variables? R and phi are variables. Theta is constant. So in this case, what is the surface area that we can expect? Tell me. What is the surface area that we can expect? So let us consider this is z axis, right? So you have to vary r and phi. Theta will be same, right? So let us say this is z axis, right? Okay. So I am varying r, right? I am varying r and I am varying phi, varying r and varying phi, vary r and vary phi, right? So this is just like this here. So let us say this is z axis, right? This is the center of the sphere. So I am varying r, right? So the angle between z axis and r is nothing but what? Theta. So I am varying r and I am varying phi. I am varying r and I am varying phi. I am varying r and I am varying phi. I am varying r and I am varying phi. Okay. So if you do this, what you are going to get? You are going to get the surface of a cone. So if you vary r and phi, vary r and phi, vary r and phi, vary r and phi, what you are going to get? You are going to get the surface area of a cone, right? Okay. Okay. So mathematically let us check whether we are getting that or not. So here you have to integrate with respect to r and with respect to phi. So let us say the range of r is from 0 to r1, phi range is from 0 to 2 pi, right? So what you are going to get? R sin theta dr d phi A theta cap. So if you do this, what you are going to get? Tell me. So integration of r dr is nothing but what? R square by 2. Its range is from 0 to r1. Next, sin theta is constant with respect to what? With respect to this integration variables. So write down sin theta simply. So take sin theta out of the integration. So you can write simply sin theta. Next, integral d phi. Integral d phi is nothing but phi. Its range is from 0 to 2 pi and its direction is nothing but A theta cap. Okay. Okay. So next here what you are going to get? Here you are going to get r1 square by 2 into what? Into sin theta into what? Into 2 pi into 2 pi A theta cap, right? Okay. So here 2 will get cancelled. So you are going to get pi into r1 square sin theta, pi into r1 square sin theta A theta cap. So pi r1 square sin theta is nothing but what? Is nothing but the surface area of a cone. This represents the surface area of a cone. So where this angle is nothing but theta. right? Okay, so this is another surface area that we got. Okay, so what are the three surfaces that we got here in a spherical coordinate system? So by varying r and theta, what is the surface area we got? By varying r and theta, we got the surface area of a semicircle. Understood? Next, by varying theta and phi, keeping r constant, if you vary theta and phi, you got what? We got sorry, we got the surface area of a sphere, right? Next, by varying phi and r, that means by varying only r and phi, what we got? By varying r and phi, we got the surface area of a cone. So these are the three surfaces we got in spherical coordinate system. One is the surface area of a semicircle, and another one is the surface area of a sphere, and the third one is the surface area of a cone. Okay, so this is called as a theta equal to constant plane, and this is called as a r equal to constant plane, and this is called as what? This is called as a phi equal to constant plane. So this is phi equal to constant plane, right? And this is r equal to constant plane, and this is what? This is a theta equal to constant plane. So these are the three planes or three surfaces that we got in case of spherical coordinate system. Right. Now, what is the differential volume here? What is the differential volume? So it is very simple here. If you want to determine the differential volume, what we have to do? What you have to do? Tell me. What you have to do? What we have to do in order to get the differential volume? Just multiply. I have already told the concept here. Right. So take any small differential area and extend that differential area in its perpendicular direction, then you are going to get the differential volume. Okay, so here we know all those things, we have already developed those concepts. Okay, here again and again there is no need to do each and every step, right? So here we can directly write the differential volume dV is equal to what? Just multiply all the three differential lengths here. We know that the differential volume is a scalar quantity. Understood? The volume is a scalar quantity, isn't it? So just multiply all the three differential lengths. What you are going to get here? Dr into r d theta into r sin theta d phi. So that is r square. R into r is r square sin theta. R square sin theta. Next, dr d theta d phi. So you are having dr d theta d phi. So this is the differential volume you are going to get. So just I have multiplied the three differential lengths. So that is r square sin theta dr d theta d phi. Understood? So if you want the total volume, what you have to do? You have to integrate with respect to r. Here the variables are r, theta and phi. Okay. So you have to integrate with respect to r, with respect to theta, and with respect to what? With respect to phi. Right. So let us say r is varying from 0 to r1, theta range is from 0 to pi, phi range is from 0 to 2 pi. Okay. Okay. So if you do this, what you are going to get? R square sin theta dr d theta d phi. So if you do this, what you are going to get? Tell me. So integration with respect to r is nothing but what? Integral r square dr, that is r cube by 3. Its range is from 0 to r1. Integral sin theta is nothing but minus cos theta. Its range is from 0 to pi. Integral d phi is nothing but phi. Its range is from 0 to 2 pi. So if you substitute this range, what you are going to get? Here you are going to get r1 cube by 3, and here cos pi is minus 1. Minus cos 0 is 1, minus 1 will become minus 2, already minus is present, minus of minus will become plus. Okay, so here you are going to get 2 here, this one you are going to get 2. Next, here if you substitute the range, you are going to get 2 pi. So 2 pi into 2 is nothing but what? 4 pi, and here 3. So here you are going to get 4 by 3 pi r1 cube. So this is the volume of what? This is the volume of the sphere. Right, this is the volume of the sphere. Okay, okay. So in this manner you have to analyze this spherical coordinate system, right? Okay, Okay, so we have learned what is r, what is theta, what is phi, and also we have seen how to convert or how to represent the spherical coordinates in terms of rectangular and rectangular in terms of spherical, and also we have seen how to represent the unit vectors ar cap, a theta cap and a phi cap. Here I have explained two methods to determine ar cap, a theta cap and a phi cap. So whatever the method that you are comfortable, you can follow that one, right? Okay, so after that we have seen how to determine the differential area, and by varying the r and theta, what is the surface area we are going to get, right? And by varying theta and phi, what is the surface area we are going to get, and by varying phi and r, what is the surface area we are going to get. So all these things including with mathematical equations we have visualized also. We have visualized those surfaces also. Understood? So what are the three surfaces we got? One is semicircle, and another one is surface area of a sphere, and another one is surface area of a cone, right? And then after that we have determined the differential volume, and from this we have determined the total volume expression. Understood? Okay, so with this almost we have completed this spherical coordinate system here, right? Okay, so in the next lecture we will try to solve some problems based on this coordinate systems, right? Okay, so I hope it is crystal clear up till now, right? Okay, so this is the end of this session here. This is the end of this session. Okay, so with this we have completed the spherical coordinate system also. In the next lecture we try to solve some few problems based on this coordinate systems, right? Okay, so I hope you are enjoying my lectures, right? So okay, then take care, bye bye, and thank you for